Okay, here's a question you see quite a bit at a junior cert exam level, especially higher. And it gives you these 6 pictures of graphs here, and it gives you 6 functions. And I want you to match each function up with its graph. Okay, so there's a process we can go through here, and hopefully I'll do that there now, and you might be able to understand it. So let's look at these. So we have a straight line graph, a straight line graph. We have, looks like, one curve this way, which is like we call happy face graphs, and this is a sad face graph. And this we don't see as much at junior cert level. So, but these lines, yeah, and these curves with one bend in them, yeah, we see a lot. So you may know that we call these graphs like a smiley face, a happy face graph. And they're what's known as positive quadratic or positive x squared type graph. So this is a positive x squared type graph. This is a positive x squared type graph, and this is a negative x squared type graph, and this is a line, and this is a line. So if you like, this is a y is equal to mx plus c type of stuff, or fx can be replaced by y, don't remember, same thing. And this is also a y is equal to mx plus c type job, yeah. And this one we don't know yet. So let's look at these. Now we can see that we have 2 positive x squareds and we have 2 lines, right? But we should have only one with a negative x squared. So straight away we should be able to see that, well, is there a negative x squared? Well, this one here, the very first one, has a negative x squared. Has anything else got a negative x squared? No. When you square out this bracket, you'll be left with a positive x squared. This is a positive x squared, 2 to the x, and this one here. No. So the only one actually with a negative x squared is this e function here. So this function here must be e of x. So we can then cross that one off as we know one. Okay? Now let's look at the 2 positive ones. What do we notice about the 2 positive ones? Well, for the 2 positive ones, let's spot something here. So how can we differentiate these two? Now, if I look at this and maybe I expand this out a little bit here. So maybe if I get a page to do that, or do it at the side here maybe, right? So let me just expand this one here out a little bit and see what I get. So for g of x, I have x minus 2 to be squared. This is my g of x. What happens if I expand it out a bit? Well, that gives me x minus 2 by x minus 2, because that's what it says I have. I have it squared. So x by x gives me x squared and a minus 2x. Then another minus 2x, and a minus 2 minus 2 gives me a plus 4. That gives me x squared minus 4x, and then plus 4. Okay? And the other one, so that's one of my quadratic expand, and the other one I had is this hx here. So what's hx look like? So hx looks like this. Now, remember something from quadratic graphs. What do we always seem to be doing in junior cert? We always seem to be factorizing them, which means set them equal to 0 and open 2 brackets. So for this one, we need 2 numbers, of course, that multiply to give us minus 6, but add up to give us the number with x. Now you can't see a number with x here, but it is positive and it is a 1. So what 2 numbers multiply to give minus 6, but add up to give plus 1? Well, that's a plus 3 by minus 2. Plus 3 minus 2 gives us minus 6, but plus 3 minus 2 gives us that plus 1. So we get down to here, and then we say x then must be equal to, you take it outside the brackets. Well, what you essentially are doing is this. You're saying x plus 3 is equal to 0, or x minus 2 is equal to 0. And if x plus 3 is equal to 0, x is equal to minus 3. Or if x minus 2 is equal to 0, x is equal to plus 2. See these 2 numbers? These are my roots, or where it breaks ground, if you like. Okay? So it breaks ground here at a minus 3 somewhere and a plus 2 somewhere. What about this one? Where does this one break ground? So let's factorize it. So what are the factors of plus 4 but add up to minus 4? So this is something you see quite a bit. It's actually, what goes negative but when you multiply it goes positive? Well, 2 negative things. So x minus 2 and x minus 2. Now look what's happened here. We take each one out, but we have the same thing twice. So we have x equal to 2 or x equal to 2. So how do I draw that? How do I draw a smiley face graph that hits at x equal to 2 twice? Well, that's known as a repeated root, or saddle point, some people call them, where it hits at 2 here. And the other one, yeah, that actually breaks ground straight through a 3 and back up at 2. And just as an extra side note, this number here hits the y-axis is always the constant on its own, so that's actually minus 6 there. But we don't need that for this. So we can see that h of x goes through the ground like this, whereas g of x actually touches off the ground. So which one goes through the ground? This one. Which one touches off the ground? This one. So therefore we said h of x must go through the ground, which makes this one, because we found two distinct roots for it. But when we did g of x and factorized it and found the roots, we can see that the roots here, now I factorized this, but I did know from the very start that this is where I had, but this is just to help your understanding, to stick with the one method for both so you know what's happening. But really you did have it factorized at the very start. So we have a repeated root here, which means it's touching at one point, so that means this one here must be g of x. So we can cross off g of x and we can cross off h of x. Now we're left with these. We're left with a number 4, a 2 to the x, and a 4 over 5x. Well, let's still kind of ignore the one that we're not sure of at the minute at junior cert level. So maybe let's look at these two lines. What do we notice about these two lines? Well, these are straight lines, which means they should not have an x squared term or an x cubed term or a 1 over x term. Anything different has to just have a standard number with the x. It kind of means that this one here is not standard with an x. It has an x in the power, so really this can't be the two of these. So what can they? So it must be either 4 or either 4 over 5x. Now what I want you to notice is the y is equal to mx plus c. What does m stand for? Well, you may know at this stage that m stands for slope. Yeah? Let's look at what the number with x is in both their equations. Here I have a number of 4 over 5 with x, giving me a slope of 4 over 5. Here I don't have any x. I have no number with the x. Well, if I have no number attached to the x, it means I have no slope. And if we look at these two graphs, we can see that one clearly is a sloping line and one is not a sloping line. One is a horizontal line. That means this line has a slope of 0. This has a slope of some value. Now, remember, it is going uphill as we come from the left on our snowboard, say. He has to go uphill, which means the slope is positive. So it's definitely a number with x that's positive. And we can see this has a positive number with x. This has no slope at all. If you were on your snowboard here, you would not be traveling anywhere. You'd stay still. You'd have a 0 slope. So we can hopefully see that this one here has no slope at 0. So therefore, this one here must be my f of x. And since this one does have a positive slope, this one does have a number attached to x given a positive slope, this one must be k of x. So we can cross those off. There's only one graph left, there's only one function left, which means this one must be our g of x. That's it. Now, the next question then says, f of x some function is equal to 2x squared plus 9. Find the values for when f of x is equal to 9x. Well, we know what f of x is. F of x is this stuff here, because we said f of x equal to that stuff. So the first thing let's do is let's set f of x equal to 9x. So that tells us that f of x being 2x squared plus 9 must be equal to 9x. This is a quadratic equation. At this stage, if you're close to your exams, you're in third year, you should know the only way we can solve our quadratic equations is by bringing everything to one side. That means bringing this 9x guy over, he becomes a minus 9x, and setting equal to 0. So you should 100% know that a quadratic equation, want to solve that for what x is going to work, we know we must bring it all to one side to equal to 0. Now we also know that we do like seeing it like this. We like seeing our x squared term first, we like seeing our x term next, and then we like seeing our constant term zone over here. How do we factorize that? Now you can go to the minus b formula here, okay, or the quadratic roots formula. If you go to the minus b formula, just note that a is equal to the number with x squared, that's 2. B is equal to the number with x, that's minus 9, very important to the minus, and c is the number on its own, which is regular 9. You can put these into the minus b formulas and it will give you two answers. What we're going to do is factorize it from our head. So not everybody will be able to do this. So we need the factors of 9 that get us to minus 9 using this 2. It turns out to be minus 3 and minus 3. Because 2x times minus 3 is minus 6x. Minus 3 times x is minus another 3x, giving us that minus 9x in the middle. Of course, we're not finished yet. That says 2x minus 3 is equal to 0. Or x minus 3 is equal to 0, meaning that x is equal to 3. Or 2x is equal to 3 when it comes over, and then x is equal to 3 over 2. So there are two values. You will hopefully get the same, well, you should get the same if you put these values into the minus b formula. So maybe if you're unsure of this, a lot of people find it tricky when there's a leading coefficient or a number attached to the x squared. But I will do a video on methods of solving quadratic equations. So, hence or otherwise, find the values of t for which f of 1 over t equals to 9 over t. Now it says hence. You maybe know at this stage that the word hence means you must use your previous answer. Not you must use, it does say otherwise here, so it means we don't have to. What have they done here? Well, it looks like they've replaced x by 1 over t. If you spotted that, you'd know that, well, if x is equal to 3 over 2 in one solution, and they've replaced my x with a 1 over t, then 1 over t must be equal to 3 over 2. A small bit of cross multiplication, which is kind of, we shouldn't be talking about too much. T goes up there, 3 comes down here, 2 can go up there. So t has to go on top, 2 comes over here on top here. T is over here, he's happy, 3 now goes below. So there's my first value for t. Otherwise, I can say the other value I got for x was equal to 3. And again, since I've replaced my x by 1 over t, 3 and t can switch places. That says 1 over 3 is equal to t. And of course, if you did not spot that, you could go ahead easily and you could just say f of 1 over t and replace that x by 1 over t. So let's just do that just in case you did that. So f of 1 over t, what's that going to give us? That's 2 times 1 over t squared, yeah, plus 9. Well, 1 over t squared, it's still 2 times this stuff. 1 squared and t squared, that's 1 over t squared, because by the rules of powers, the 2 comes in and affects both. But of course, 1 squared is just 1, plus 9. And that gives me 2 times 1, which is 2, over t squared, plus 9. Yeah? But of course, now to that equal to 9 over t. So, how do I solve this now? Well, I'm going to multiply across by t squared. That's going to get rid of my t squared in the bottom here, leaving me a 2. It's going to multiply that 9 by t squared. And of course, 9t squared over t. I'll write it out just to take baby steps. That's going to cancel one of the t's on top. So it's going to leave me an equation like this to solve. And of course, I bring it all to one side, leading with my t squared. 9t comes over, and 2 stays there. And of course, how do you solve this? Well, unfortunately, it's back to our minus b formula, friend. And where our a here is 9, where our b is minus 9, and where our c is 2. And if you do this, you will actually get these two answers. So I'll leave that for you to do, but maybe if you spot it the first time, they've just replaced 1 over t, or x with 1 over t. You've already found values for x, so let's set each of those values equal to 1 over t and solve that for t. That's that part. So on to the next question, and it says the graph shown is given by the function f of x equal to x squared plus ax plus b. So it's some quadratic type graph, and yeah, it's a positive x squared, a happy face. And it gives it here, but it gives you two specific points, p and q, where p is minus 2, minus 5, and q is 1 and 4. It says write two equations using a and b's, basically, in the equations, but from the points p and q. Now I want you to remember that a function works like this. A function is where you have f of x, right, is equal to some stuff, where you put in a number for x and you get out a number for y. Okay, so you replace x by 1, you run it through the function, it gives you a y value, and both of those numbers come together to your coordinates, some x1, y1. Okay, that's like a side note of what functions does. So how can we use that here? Well, we can say that we know that if we run minus 2 through our function, we should get back a y value of minus 5. So for us, let's do the first equation. So f of minus 2. So using p, we know of course that in functions we replace the x by this value now. So minus 2 in for x. Don't forget it's squared, plus a times minus 2 plus b. And if we have done this for this function, we should get a y value of what for that minus 2? We should get minus 5. So we tidy up this a bit. Minus 2 squared is a plus 4. A times minus 2 is minus 2a. Plus b is equal to minus 5. Let's keep the a's and b's on this side and bring this number over here. So that gives us minus 2a plus b is equal to minus 5, but now a minus 4. That's going to give us a minus 9 over here. So here's our first equation in a and b. Now let's get the next one. That's this time f of what x value? It's 1. So if we run 1 through this function, that's 1 squared plus a times 1 plus b. We should get the value out for 1, a corresponding y value of 4. 1 squared is 1. A times 1 is a, plus b is equal to 4. And of course he comes across, becomes a minus. A plus b now is equal to 4 minus 1, which is equal to 3. So we now have our two functions, okay, in a's and b's. But when we get that, the next part wants us to solve for a and b. Okay? So, well, we have two equations and we have two variables. This is a classic simultaneous equation. So, having a simultaneous equation, let's write them over each other. Okay, so let's write minus 2a plus b equals to minus 9. That's my a equation. Over my b equation, which now is going to be a plus b equals to 3. So how am I going to make these match up? Well, if I multiply this bottom one here by 2, that gives me a 2a on the bottom and a minus 2 in the top. That cancel nicely. So let's move that over here. So I now have minus 2a. I've done nothing to the top line. And the bottom line multiplied across by 2. That gives me 2a. And now 2 times b and 2 times 3. Okay? We draw our line underneath. These are gone because they add to cancel. b and 2b, that's 3b. Minus 9 and a plus 6, that is a minus 3. So now b must be equal to minus 3 over 3, which is equal to minus 1. So our b value is minus 1. How do we get our a value? Well, we sub this b value back in here to this equation here. So we can now say that b is equal to a plus brackets minus 1 equals to 3. That's a minus 1. Then equals to 3. A then is equal to 3. This guy comes over, becomes a plus. 3 plus 1 is 4. So when all said and done, then we know that our function fx, which was equal to x squared plus ax plus b, which is this stuff here, well, we know that our a's and b's, so we can definitively say that fx is equal to x squared. What's our a value? It's 4, so that's going to be a plus 4x. And what's our b value? Well, it's minus 1. So that's our function now. So then the next part then it asks us two things. Right? It says, can you find the coordinates of the y where it intercepts the y-axis? So where does it cut the y-axis? Well, something you should know is that a function or a line or whatever, a function cuts the y-axis when x is equal to 0. That's something you have to know going into your exam, that a function cuts the y-axis when x equal to 0. Yeah. So let's write out our function. We have f of x, and we just figured this out in the last part, x squared plus 4x minus 1. Therefore, when x equal to 0, so let's replace this x by 0. 0 squared plus 4 times 0 minus 1. Well, that all leaves us, there you go, just with a minus 1. So we've put in 0, we got back a minus 1, so therefore the point is 0 minus 1. That is where it cuts the y-axis. And then the last part it says is, where does it cut the x-axis. Well, very similarly to this statement, it cuts the x-axis when y is equal to 0. But of course, you may be confused if you're still unsure. I don't see a y here. Functions often can be called, teachers say f of x may be equal to y. Really, like, we're called y equal to mx plus c, or a line equation with y is essentially a function as well. But we usually just see that with lines. But now y is equal to something here. F of x and y are interchangeable here for us. So for us, we would have something like this. And of course, if now it cuts the x-axis, this implies that y must be equal to 0. So it's exactly like that statement, we just switched around. Therefore, we're now saying 0 equals to x squared plus 4x minus 1. Now what do we have? Well, we have a quadratic equation equal to 0. How do we solve this? Well, you know we always open two brackets, or failing that, if we can't see the factor simply enough, we have to use the minus b formula. Now the question does say correct to one decimal place. That is an absolute giveaway that it's definitely going to be the minus b formula. Correct to one decimal. So using the minus b formula, let's be super careful. Let's always write the formula and what a, b and c is equal to. So minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, let's not forget, this is not something we have to learn off. This is called the quadratic roots, more commonly known as minus b formula, the quadratic roots formula. And of course that you will have on the day because it is given in the logbook. So no need to learn that off. Okay, now I am a big fan of doing this. A equals to, b equals to, and c equals to. So what's a? A is the coefficient with squared term, so that's going to be 1 in our case because we don't see anything there. B is the coefficient with x, which is a 4, and c is number on its own, which is minus 1. So this will give us this. So minus b, that's going to be a minus whatever b is, minus 4, plus or minus the square root of b squared, that's 4 squared, minus 4 times a, which is 1, times c, which is minus 1. And that's all over 2 times a, which is 2 times 1. So let's break this down a little bit before we put it into a calculator, so we don't want to make any mess ups here. So minus 4 simply stays as it is, plus or minus under the square root. Now 4 to be squared is 16. Minus 4 by 1 is minus 4. Minus 4 then by minus 1 makes it a plus 4. All over 2, that's minus 4 plus or minus square root of 20 over 2. So now we have two answers. We can't get square root of 20. But what we can do is we can say it's either minus 4 plus root 20 over 2 or minus 4 minus root 20 over 2. So we split this plus or minus into two different answers. That's what we have. So let's put each of these into our calculator. Let's do the first one. So minus 4 plus root 20 over 2 equals, and let's do s to d, so that gives us point, it says 1 decimal place, so 0.236 is what we have here, which is the equivalent of 0.2 to 1 decimal place. Now we go back in here and change that sign to a minus and see what we get, and we get a minus 4.236, and to 1 decimal place, of course, that's equivalent to, or approximately, minus 4.2. So actually we do have our two x values. X is approximately 0.2, that's what the equals with a small squiggly line means, and x is also approximately minus 4.2. So they are our two crossings. Now we need to just find the x-intercepts. It doesn't actually ask you to find coordinates, so no need to put this into an x1, y1 format here. So just your two x values is all you actually need. And that's it.